Hello everyone, my name is Praveen Manoj Sesagar. I am a trainee programmer at Yes Technology with a strong interest in building real world applications using .NET, AI, and cloud technologies. Today, I am excited to share one of my projects, ResumePulse. Now, imagine this: you spend hours perfecting your resume, you hit submit, and then no response. Frustrating, right? But what if an AI could tell you before you even apply how well your resume matches the job, what score you might get, which skills you already have, which ones you are missing, and whether you are a strong candidate or not? That's exactly what ResumePulse does. In this video, I will show you how I built it, a fully deployed AI powered resume analyzer running on Microsoft Azure free trial. And I will walk you through everything from Azure setup to the code to deployment step by step. Now, exactly what is ResumePulse? The problem is that this is not just a portfolio project. In real life, companies receive hundreds of resumes for a single job posting. HR teams spends hours manually screening them. With ResumePulse, that becomes instant. For job seekers, it tells you exactly which skills to add before applying. For recruiters, it ranks candidates automatically. This is a real world problem solved with cloud technology. Now, let me demonstrate the ResumePulse project. Here, user needs to enter the email, job description, and upload one of the resume. Now, let me enter my email. Then I will put a dummy job description as a software developer. Then I will upload one of my resume. Now, when I click analyze my resume, you can see the tracking of processing your resume. First, resume is uploaded to the secure cloud storage. Then it will queue for analysis. Then AI will analyze the resume. For AI, I have used the Gemini AI. After AI analyzes the resume, the report is generated and email is sent. As you can see, I have got 78 out of 100. Here we can see the score summary, the skills we have present in our resume and the skills which are missing. We can also analyze another resume. So this is a simple but very good project. Now let me tell you what technology I have used to build this particular project. For frontend UI, I have used the Blazor WebAssembly. For REST endpoint or backend, I have used ASP.NET Core API. For securing the secrets, I have used Key Vault. For storing the PDF as well as report, I have used the blob storage Azure service. For queuing the message, I have used the service bus. For serverless compute, I have used Azure function. For resume to be analysis, I have used Gemini AI. For event routing, I have used Event Grid. And for email workflow, I have used the Logic app, which is an workflow automation. And for email delivery, I have used SendGrid. And for hosting the Blazor frontend, I have used Static Web by Azure Resource. So that's it. Today's video cover setting up 8 Azure services, writing the backend API in .NET 9, integrating Google Gemini AI for analysis, building the Blazor WebAssembly frontend, and deploying everything to Azure, all for free. Let's get started. Before writing any code, let me show you the architecture, how all the pieces connect. Understanding this is the difference between copying code and actually understanding cloud development. Now, let me tell you complete end-to-end flow. First, user open Blazor WebAssembly web app in browser, fills email, job description, upload PDF resume. Then the Blazor UI calls post method to the ASP.NET Core API. Then the API read secret from Azure Key Vault, storage plus service bus keys. Then API upload PDF to the Azure Blob Storage, which is resume container, and it get back the blob URL. After that, the API sends message to Azure Service Bus queue with job ID, blob URL, email, and job description. After analyzing the resume, the API returns job ID status immediately to the user without waiting. Then Azure function is triggered. ServiceBusTrigger fires automatically. That downloads PDF from blob storage. Then Azure function extract text from PDF, calls Gemini AI with resume text plus job description. Then the Gemini AI returns JSON with score, summary, match skills, missing skills, and recommendation. Then the function saves report.json to the blob storage to the report container. Then the function publishes resume analysis completed event to the Azure event grid topic. Then the logic app event grid triggers logic app pass event data sends email via send grid. Then the Blazor UI calls get method every 5 seconds and then shows result when ready. This is an event driven pattern. Notice the API returns immediately after putting the job in the queue. It doesn't wait for the AI. This is called an event driven architecture. It's how Netflix, Uber, and Amazon build their systems. The benefits: fast user experience, services are decoupled, and the system scales automatically. The proper complete end to end flow is given in the PPT as well. User uploads resume, API stores PDF in blob storage, then the message queued in service bus, then the Azure function is triggered. Gemini AI analysis resume versus job description, then report is saved to the blob, then event grid fire, and logic app sends email via send grid. Now, let me explain each and every Azure service we will use. For each one, I will tell you what it is, why we choose it, and exactly where it fits in our project. We will start with the Azure Blob Storage. So, what exactly is Azure Blob Storage? So, it is an cloud based Google Drive for your application. It stores unstructured data, files like PDF, images, JSON files, cheaply and reliably at massive scale. It required no server. Why we use it? We need to store uploaded PDF resumes and generated JSON report files. Blob storage costs almost nothing for storing small amount of data and is built into every Azure subscription. The free tier gives 5 GB. So how it fits in our project? The API uploads resume PDF to the resumes container. Azure function saves report.json to the reports container. The Blazor frontend reads the report from there via the API. So we use Azure Blob Storage as a storage to store the PDF files. Now, second is, what is Azure Service Bus? So Azure Service Bus is a message queue service. Think of it like a post office. You drop a letter and the worker picks it up and processes it when ready. Here, letter is nothing but a message and the worker is nothing but the Azure function. Messages are guaranteed to be delivered. Why we use it? We don't want the API to wait 30 seconds for Gemini AI to finish. Service bus decouples the request from the processing. Even if the function crashes, the message stays in the queue and retries automatically. So how we use it in our project? API puts a JSON message, job ID, blob URL, email, job description into the resume analysis queue. The Azure function has a service bus trigger. It wakes up automatically when a message arrives. Now third, what is Azure Key Vault? Azure Key Vault is a secure digital safe in the cloud. It stores password, API keys, connection string, and certificate. Nothing sensitive ever goes in your code or configuration files. Why we use it? Our app has sensitive secret, storage connection string, service bus connection string, Gemini API key, event grid key. Hard coding this is a security disaster. Key Vault keeps them safe and auditable. How it fits? We store all secrets in Key Vault. App service and function authenticate using managed identity, which is passwordless. In code, we use add Azure Key Vault, which pulls all secrets automatically at startups. And the fourth one is Azure App Service, which is a fully managed platform for hosting web application. No server management. You give it your .NET app and Azure handles the server, OS updates, scaling and HTTPS. No server management needed. Why we use it? We need to host our ASP.NET Core API somewhere on the internet so the frontend can call it. App Service F1 free plan gives us one small app for free with a public URL. So how it fits? We deploy our ResumePulse.api project here. It gets a URL like app.resumepulse. The Blazor frontend calls this URL to upload resume and fetch reports. Now let us see app service plan. So what is an app service plan? It is an underlying compute resource that app service runs on. Think of it as the server size you are renting. The app service plan defines the CPU, RAM and pricing tier. Why we use it? Every app service needs a plan. The F1 free plan gives 1 GB RAM and 1 GB storage at zero cost. It's perfect for demos and portfolio projects. For production, you would use B1 or higher. How it fits? We create one app service plan on the free tier. Our API app service is attached to this plan. The plan determines how many resources the app can use. The next one is Azure function. Azure function is an serverless compute. Write a function. Azure runs it when triggered. You pay per execution. No server to manage, no idle cost, infinite scale. The consumption plan gives 1 million free executions per month. Why we use it? Our resume analysis logic needs to run in background triggered by service bus. Functions are perfect for this. They wake up on demand, process the job and sleep again. No wasted resources. How it fits? Resume analysis function uses ServiceBusTrigger attribute in our project. Azure automatically invokes it when a message arrives. It downloads the PDF, calls Gemini AI, saves the report, and fires an event grid event. Now, what basically Azure Event Grid is? So, it is a fully managed event routing service. It connects event publisher, that is our code, to event subscribers, that is logic app, functions, etc. Think of it as a notification system for your cloud infrastructure. Why we use it? After analysis is complete, we need to trigger an email notification. Instead of calling the email service directly from the function, which can lead to tight coupling, we publish an event, that is event grid. Event grid routes it to whoever cares. How it fits? The function publishes a resume analysis completed event to the event grid topic. Event grid routes this to the logic app subscription. The logic app then sends the email automatically. As you can see, I have used the logic app. Now, what basically is the Azure logic app? So, it is a no-code, low-code workflow automation service. You build workflows visually, like connecting Lego blocks. It has 400 plus built-in connectors for Gmail, Office 365, SendGrid, Slack, and more. Why we use it? We need to send a formatted email when analysis completes. Instead of writing email sending code and managing SMTP credential, we use logic apps. It handles the SendGrid integration with zero code, as it is an automation workflow. How it fits? Logic app listens for event grid events of type resume analysis completed. When triggered, it passes the event data, that is code, skills, email, and uses the SendGrid connector to send the formatted result email. Now, what is Azure Static Web App? So, a static web app is a hosting service specifically designed for static front-end application, HTML, CSS, JavaScript, and WebAssembly files. It includes free global CDN, HTTPS, and custom domains. Why we need it? Blazor WebAssembly compiles to the satisfy HTML plus WebAssembly. We can't just deploy it to the app service easily. Static web app is built exactly for this. Free trial, global CDN, instant deployment. How it fits? We deploy the compiled Blade WebAssembly output, the www root folder, to Azure Static Web Apps. Users worldwide get fast load times because the files are served from the nearest CDN edge location. So this is the all about Azure service we will use in our project. Now let us understand what is the difference between app service plan, manage identity and environment variable. So first of all, what is app service plan and app service? App service plan is the server, like renting a virtual machine, defines CPU, RAM, OS, pricing tier. And what is app service? Your application that is hosted on that server. One plan equals to many apps. There are four pricing tiers: F1 free, B1 basic, S1 standard, P1 V3 premium. We will going to use F1 free for development as well as for demo. The key app service feature we will use environment variable to store non-secret config with, that is key vault URL, container names, etc. We can set via portal under the configuration app setting or CLI. Then what is managed identity? Gives the app service a passwordless Azure AD identity used to access key vault without storing any credential. We are going to use F1 free pricing tier. Free F1 plan apps goes to sleep after inactivity. First request wake up them, which is also called as cold start. B1 plus has always on. Then what is deployment slot? Blue green deployment. Deploy to the staging slot, test, then swap to production with zero time. Let's set up all the Azure resources. I will show you one way to do everything using the Azure portal. The portal is great for learning. Now open portal.azure.com in your browser and sign in with your Microsoft account. If you don't have one, create a free account at azure.microsoft.com/free. You will get $200 credit and free services forever. Now let me show you how we can build exactly this project from step 1. Before going forward, let me tell you how ResumePulse works. There are 10 total steps. Step 1, user interface. User submits their resume. What happens, sir? The Blazor frontends collect name, role and resume text, builds a JSON payload and sends an HTTP post to ASP.NET Core API hosted on Azure App Service. The frontend is entirely static, no server needed to run it. Now, when I click Analyze Resume, it will take me to the step 2. Step 2 is nothing but the ASP.NET Core API receives the request. The API acts as a gateway. It validates the request, fetches secrets securely from Key Vault, then hands off work to the messaging layer. We have used the .NET 9 runtime and we have hosted it on App Service Plan B1 and we have used the Manage Identity. Why Key Vault here? The API never stores connection string in app setting.json. Instead, it uses Manage Identity to authenticate to Azure Key Vault at runtime and fetches the OpenAI key, where we have used the Gemini AI key, service bus connection and storage account key on demand, zero secrets in code. Then going to step 3. Step 3 is nothing but the Azure Key Vault protects all secrets. Key Vault is the security backbone. No credential ever touches source code or environment variable. Access is controlled through Azure role-based access control role. We have used the IBSC access model. We have used the manage identity as a caller. We have assigned the role as Key Vault secret user and scope is per resource group. So why not app setting? If you commit secrets to Git or pass them as env variables, they can leak. Key Vault gives you audit logs, version control for secrets, soft deletion protection, and zero secret in code architecture. Step 4 is an Azure Service Bus queues the job. Instead of calling Gemini AI directly and blocking the HTTP thread, the API drops a message in Service Bus. This decouples the frontend from the AI processing. The API responds instantly. We have used the standard tier FIFO type 3 and the max delivery count is 3 attempts. It will get to the dead letter after 3 fails. Why Service Bus and not direct HTTP? If Gemini AI takes 10 seconds, a direct HTTP call blocks the user browser. With Service Bus, the API returns 202 accepted immediately. The queue also handles retries automatically. If the Azure function crashes, the message stays in the queue and gets retried 3 times before going to dead letter. Then the step 5. Step 5 is the Azure functions processes the analysis. Two functions run in the isolated worker model. The first triggers on the service bus message and calls Gemini AI. The second publishes the result to event grid. We have used the two functions, resume analyzer function and result publisher function. Resume analyzer function triggered by service bus queue message. Deserialize the payload, calls Gemini AI Gemini 3 flash preview model with a structured prompt asking for ETS code, skill gaps, and suggestion. Saves new result to blob storage. Then result publisher function. After saving to blob, reads the result and publishes a custom event to event grid. The event carries the job ID, user email, score, and result blob URL. This triggers the email notification chain. Step 6 is about the Azure Blob Storage persists the result. The AI generated analysis JSON is saved as a blob. This serves as the durable record and also triggers subsequent functions via blob URL reference in event. Here also we have used the standard LRS style. LRS is nothing but the local redundant system. Why store in blob? As a function output binding, let you write to the blob storage without any SDK code. Just decorate your function, return value. The blob URL is then passed into the event grid event so downstream services know where to find the full result. Step 7. Event grid draws the analysis done event. Event grid is the event broker. When the function publishes a resume analysis event, event grid fans it out to all subscribers, logic app, web hooks, or other function. What is different between Service Bus and Event Grid? Service Bus is for reliable message queuing commands. Event Grid is for event notification. Service Bus guarantees deliver, order, and retry. Event Grid is optimized for high throughput fan out. Step 8. Notifications. Logic app plus SendGrid send the email. A Logic app workflow triggers on the Event Grid event and sends a beautifully formatted result email using SendGrid, all without writing any code. Here you can see the formatted email. Then we have the step 9, observability. Application insights monitor everything. Application insights give you end-to-end tracing, live metrics, and failure alerts across all your Azure services. One place to debug the whole flow. E2E trace. Because every service is instrumented, you can click one request in App Insight and see the full journey. HTTP to Service Bus to function to Gemini call to blob write to event grid and the last logic app and all with timing and any errors highlighted. Step 10. The full ResumePulse architecture. Every Azure service, what is there and how they all connect. This is our POC. A real production grade event driven architecture on Azure. Okay, so let's start building our project. I assume you all have Azure subscription of your own. So now let's start with step 1, creating a resource group. So what is a resource group? So a resource group is like a project folder in Azure. All resources for one project go in the same group. This makes it easy to manage, monitor cost, and delete everything at once when done. So go to portal.azure.com, search resource group in the top search bar. Click resource group in the result. Click create and fill in all the details. RG stand for resource group. ResumePulse and my initials, and click review plus create. Now as a resource group is created, now step 2, create storage account. Go in the search bar and type storage account and click on storage account. So what is storage account? A storage account is the parent resource that contains Azure Blob Storage. Think of it as the hard drive, and blob containers are the folder inside it. Now click create button. Subscription, you have free subscription, and resource group created just now, and storage account name stream pulse pk, and region should be the same, and for redundancy select the LRS and click view plus create. It will take some time to validate. After validation, click create to proceed further, and make sure you have selected performance as standard, and when validation is done, click create. You can click on the notification to see the deployment. You can remove all the existing notifications. Okay, so once the deployment is done, go to the resource, go to the data storage. Under data storage there is a folder called container. Click on that. After going there, click on add container, add the name as resumes, and anonymous access level will be private, and click create. It will create the resume folder in the storage, and repeat the same for reports as well. Once it is done, go to the access control, which stand for identity access management. Click on add and click on add role assignment. Search for blob data contributor, storage blob data contributor, and click next. After that, select member and click on your account name. After it is done, click on select and click next and review plus assign. Now we will move forward to the step 3, is nothing but the creating Azure Key Vault. So why Key Vault before everything else? First we will understand that. We create Key Vault first because we will store the other services connection string in it as we create them. This way we never need to write secrets anywhere else. So type Key Vaults in the search bar. Click on Key Vaults. Click on create. Select the free Azure subscription. Click the resource group we have created. Give the Key Vault name. I will give as KV. KV stand for Key Vault hyphen ResumePulse.pk. I will select the region as East US and pricing tier as standard, and day to return I will select as 7 and click next, click next, click next, and click review plus create. It will also validate the Key Vault. After it's done validation, you can click on create button. Also make sure in access configuration tab, select Azure role based access control. This is more secure than access policy. This one. Once all the things are done, you can click create button. Deployment is done. We have completed the step 3A. Now we will go to step 3B, add secret to the key vault. So what secret do we store? We will store storage connection string for blob storage. Then we will store service bus connection string for service bus. Then Gemini API key, event get topic key. So open key vault. Then add. Then under object, click secrets. In secret, click on generate import and give and add the all necessary connections. Add the secret. So first one is a storage connection string. Now from where we will get this storage connection here? Search storage account. Click it on open in new tab. Click your account. Go to your storage account. Go to the security plus networking. Then go to the access keys. Then copy the connection string for key 1. Go back to your secret. Enter the secret value and click create. To view the all the secret, go back to the access control. Click on add role assignment. Search secret key vault officer. This one. Then click next. Click on select member. Click on your account. Click select and click review plus assign. Once it is done, go back to secrets and click refresh. If the secrets are not available or not visible, uh, do the step once again. Click generate. Give the name storage connection string. Enter your connection string. Click create. Once it is done, you can able to see the storage connection string. Repeat the step for Gemini API key. I already have the API key, so I will copy that. I have added the secret value for Gemini API key and I will click on create. Now for adding the service bus connection string, first of all we need to create the Azure service bus. So first of all we will create that. Now enter service bus in search bar and click on service bus. Then click on create. Enter the subscription. Enter the resource group. Give the namespace. I will give the namespace as the SB hyphen ResumePulse hyphen PK. Then I will select location as East US and pricing tier as basic. It tells that namespace already exists, so I will give the different name. Service bus service. Click on review plus create. It will take some time to validate. After validation is done, you can click the create button. So the validation is succeeded. Click on create button. After namespace is created, click on the namespace. Click on queue. Give the name as Zoom Analysis Queue. Give the max queue size as 1 GB. Click the max delivery count as 3. Give the log duration as 2 minutes. And click on and check the enable date lettering and click create. Once the queue is generated, you can see the queue below the queue section. Now go to the shared access policy. Go to the root manage shared access key. Copy the primary connection string. Go back to your key vault. Click on your key vault name. Go to the secrets under the object tab. Click plus generate and import. Give your name service bus connection string. Enter your secret and click create button. Once it is done, now we will create the app service plan. Now search app services in search bar. Click on app services. Then click on create. Then click on web app. Then select your Azure subscription. Then select your group and then give the name. I will give it at app hyphen ResumePulse hyphen pk, and I will select the code and I will give the runtime stack as .NET 9. I will select Linux. I will select region as East US. I will click on create new plan and I will give the app service plan name as ASP hyphen ResumePulse hyphen pk. Click on OK. Select the pricing plan as free F1. Then click on next. Then click on next. And for basic authentication under the deployment tab, give it enable. Then go to the next. Go to the next. Next. And click create. While it is validating, go to your new tab under key vault section. Select the vault URI. Copy to clipboard and go back to your web app. Once the deployment is done, go to the resource. Under the settings, go to the environment variable. Click on add. Give the name as key vault underscore URI, or you can give underscore URL and put the value as the connection string or key vault URI as we have selected it. Then click on apply. Then click on apply. Click on confirm. Go back to overview. and restart the app. Now to do the further step, we require VS Code. Make sure you have VS Code installed. Now click on Ctrl plus Z. It will open the terminal in your VS Code. Now enter the command AZ login. Make sure you have Azure CLI installed in your desktop and make sure you log in the Azure account in your VS Code as well. Once the login is done, you will get your subscription name. Enter 1. Now you have login to the Azure in your VS Code. Now enter the command as shown here. Here you will get the principal ID, tenant ID, type, user assigned identities. We will need the principal ID. Now enter the second command. Copy the principal ID. Once it is done, then we will create Azure Function app. Now for Azure Function app, you will need to install some of the Azure extension in your VS Code. Let me show you that. We will create Azure function through VS Code. So we need some of the extension to be installed. So you can install some of the extension. First one is a Azure Function app, Azure Container app, Azure App Service, Azure MCP Server, Azure Developer CLI, Azure Pipeline, Azure Write, Azure Resources, Azure Static Web App. After installing all the extension, click on Azure, then select the subscription. You need to log into the account. You can click on plus, allow. Once you have the Azure account, you will able to see the Azure subscription on the resources tab. Right click on the function app, create function app in Azure, enter the function app name. I will give func ResumePulse -pk. I will give the location as East US. I will select the .NET 9. I will select the manage identity as an authentication type. So it will create my function app in the Azure portal. We need to wait for 1 to 2 minutes or it will take less than 2 minutes. Now here you can see that it is creating its own app service plan and storage account. So we need to navigate this function app to our storage account. So we will do that next step. Once the function app is created, navigate to the Azure portal. Once you navigate to the Azure portal, search function app in the search bar. Refresh the page. Select your function app name. Go to the identity under the settings tab. Under the system assign, select the status as on and click on save. Copy the principal ID. Go to the key vault. Go to the access policies or access control. Click on add role assignment. Select the role as Key Vault Secret Officer. Click on next. Select the manage identity. Click on select members. Select the manage identity as user assign manage identity. Select the member and click on select and click review plus assign. Once it is done, in another tab, go to your storage account. Go to the access keys under security plus networking tab. Copy the connection string for the key one. Go back to another tab. Select the function app. Select your function app. In the environment variable, here we need to change the name to the R storage account. So copy R storage account name. Go here and change all this func ResumePulse pk. Click here and change this one. Do it for all. Click on add and add Azure Web Jobs Storage. Copy the connection string and paste it here and click on apply. Now go back to under deployment setting. Select the storage account as StreamPulse pk and container as resumes and click save. Go to the overview and click on refresh and restart the function app. Now go to the resource group, search in the search bar and go to the resource group. Select the function ResumePulse pk. Select the log analytics. Select the application insight. Select the function app and select the app service plan. Click on three dots. Click on move and move to another resource. Select the resource group we have created. Click on next. It will first validate the status whether it is possible to move to the another resource group. Once it is done, then we can click on next. Once all the validator status is succeeded, click on next. Check the box and click on move. It will take some time. Once it is done, refresh the page and click on overview under the function ResumePulse wiki and click refresh. The storage account and delete it. As we have created our own storage account. Don't delete the manage identity. It is compulsory to stay here. Let us move to the step 7. Create event grid topic. Search event grid topic in the search bar. Click on create. Select the resource group. Give the name. Select the region as East US. Click on next. Click on next. Click on next. Select the event schema as event grid schema and click on review plus create. Validation is succeeded. Now click on create. Wait for the deployment to be completed. Once the deployment is completed, go to the resource. Go to the settings. Go to the access keys. Select the key one. Then in another tab, go to the key vaults. After selecting the key vault, go to your key vault. In the secrets tab, click on generate and import. Give the name as event grid topic. Once it is done, now we will go to the step 8. Create logic app. Search for the logic app. Create the logic app. Select the consumption type and click select. Give the resource name, then give the logic app name. Give the region as East US. Click on review plus create. It will take some time to validate. Once the validation is done, click on create. Once the deployment is done, go to the resource. Then go to the development tools. Then click on logic app designer. Now in here, click on add a trigger. Here, search for the when a resource occur. Click on it. Then create a new connection. Sign in to your Azure account. Type as Microsoft Event Grid topic. For subscription, select your subscription. For resource name, give the resource name as EDTS ResumePulse PK. And for event type item, select the ResumePulse dot resume analysis completed. Click on save. After that, click on plus button. Here, click and add an action. Now here, search for past JSON and select the event data. And for schema, enter the schema. Then click on save. I will provide all the files in the description below. Once it is done, click on plus icon and click add an agent. Then here we need to select send email. Under the send grid section, click on send email. For SendGrid API key, you can navigate to the SendGrid. Yeah, go to the SendGrid. Enter your email. Once you are logged in, under the setting, go to the API keys. Then create new API key. Give the API key name as ResumePulse -key 2. Copy the key. Go back to your Logic app and give the API key here and click on create new. Note that SendGrid offers 100 free emails per day forever. Sign up at signup.sendgrid.com. No credit card is required, and verify your sender email address. You will need the API key for the Logic app. You can verify your email address when you go to the setting to the sender authentication, and here you can verify your address. After verifying your address, you can go back to settings and create the API key. Once it is done, give your email. Then for to select the body applicant email, and for subject give ResumePulse analysis result and select body recommendation. For email body you can give, then click on save. Now we'll go to the step 9, create Azure static web app for Blazor. Search static web app and click on static web app and click on create button. Select your subscription, select your resource group, select your name. The name should be unique. The plan type should be free, and for reason click review plus create. Once the validation is done, click on Create. We have completed with our setup of all Azure services. Now we will move forward and write code in our VS Code. Let's start with that. On your desktop, create a new file called ResumePulse. After creating the folder, open it with the VS Code. Now let's set up our project in Visual Studio Code. I will show you exactly what to install, how to create the folder structure, and how to scaffold each project from scratch. Now let me tell you required VS Code extension. Install this first. First you need to install CHasDevKit. After installing CHasDevKit, you have to install Azure Functions. After installing Azure Function, you need to install Azure App Service. After installing Azure App Service, you need to install Azure Static Web Apps. After installing Azure Static Web App, you need to install Azure Resources. Af- After After installing Azure Resources, you need to install Reset Client. After installing Azure Resources, you need to install REST Client. Once you are done by installing all the required extension, click on Ctrl plus J. It will open terminal in your VS Code. Now we need to create folder for each API, client as well as function. Make sure you have installed .NET in your desktop. First of all, we need to make an solution file. The command is these commands create the solution file that holds reference to all your project. Think of it as the master file that knows about all sub-projects. Once the solution file is created, we will create the API project. For that, the command is after creating the API file, we will create the WebAssembly file. After creating the client file, we will create the function folder. Now we need to add all projects to the solution. Once all the projects are added to the solution file, now we will need to write all the files in each of the folders. I will provide all the files as a text file in the description. I will come back after adding all the files. I will explain each and every file step by step. I have added all the code files in the each of the particular folder. Now I will explain each and every file that I have added in the folder. I will start with the ResumePulse.api. Let me explain what the folder contains. The folder contains program.cs file. So what does program.cs do? So program.cs is the entry point and configuration file for the ASP.NET Core application. It sets up the key vault integration, cost policy, that is cross origin resource policy, who can tell the API or call the API, service registration, that is dependency injection, and the middleware pipeline. So let me explain key sections of the program.cs. So the step 1 is about the key vault. It reads the key vault URL from the environment. Step 2 is that it connects to the key vault using manage identity, which is password led. Third one is a setting of the cost policy. Cost policy stand for cross origin resource policy, so that the front end can access to the backend API. Then fourth one is the dependency injection, where we have registered the services. So in this case we have used two services files, that is blob storage service and service bus service, and these are used to build the application and run the application, where we are going to use Swagger for testing the API. Now, what is default Azure credential? So default Azure credential is a magic class from the Azure SDK. It tries multiple authentication method automatically. Manage identity, Visual Studio login, Azure CLI login, etc. This means the same code works both locally in the cloud without any changes. Means it will run the program file in the locally as well as in the cloud. Now, what is controller? So I have added one file, that is resumecontroller.cs. So step 1, generate unique ID for this job. So for each file we have to add a unique ID, so that we can call the file with that unique ID. Step 2, upload PDF to the blob storage. Third step, queuing the job. It will not wait for the AI to give a response immediately. It will wait for some time, and if the connection is gone or any network error has happened, it will remain in the message queue, so that when the internet is back, it will automatically run the or queue the job. Now, what is report polling endpoint? So, it try to find the report file in the blob storage. If file doesn't exist yet, it return 404, and if the analysis is still running, and if file exists, it downloads and return the report.json. So this is all about the resumecontroller.cs. Now let me explain you the services. So we have used the two services files. One is blob storage service and second one is a service bus service. Now let me explain you what is blob storage service. Now it get reference to the resume container, then it create container. If it doesn't exist, it will check the configuration from the key vault, so that if the storage connection string is missing, it will give us error, or it will tell us to check the key vault whether the string is present in the key vault or not. Then we then the part is uploaded for the blob to where it can store the blob to the container in the cloud. Then third step is upload the file stream with correct content type. When the file is uploaded, it will take the file name as well as its content, so that it can store it into the blob storage. Then it returns the public URL of that uploaded file. When we click on that URL, we can able to get that file which we have uploaded. Now, what is service bus service? Now, it is a message queuing service where it convert the object to the JSON settings. It will convert to object to the JSON setting. Then it create a service bus message from the JSON, and it sends the message to the queue. Azure function will pick this up automatically. Let me explain you the model file. So, a model file in ASP.NET is used to define the shape of data. Think of it as a blueprint. It tells the system what information to expect and what information to send back. So, why it is important? Models make sure data is organized and consistent when moving between the front end and the back end. Example, resume upload request. So, it tells us what the user gives us, means the user inputs to the applicant, and what is resume upload response, what we are giving back to the user, what is AI giving back to the user. So this is all about the model. Model is nothing but a blueprint. They define what data goes in and what comes next. Now next is app settings files. Now these files are configuration files. They don't contain code, but they tell the app how to behave in different environment. They are written in JSON format, that is key value pairs. Why it is important? Instead of hard coding secrets or value inside code, we keep them in settings file so they can be changed easily without touching the code. Now, what is app setting.json file? The app setting.json file, it is the base setting file. It contains the general rules like logging level and allowed host. It is used by all the environment as a starting point. Then the next is app setting.development.json. So it is a special setting for development mode when developers are testing locally. It includes test connection to Azure Key Vault, Azure Storage, and Service Bus. It ensures developers don't accidentally use real production data. Now, the third setting is app setting.production.json. So it is a special setting for production mode. It is like a development, but now it is a production, means in the cloud what we are storing. So it used to connect to the actual Azure services. It keeps sensitive data like connection string hidden in Key Vault. It ensures the app runs safely and securely in real world. Now next, I will like to show you the function folder. Let me explain you the ResumePulse.function folder. It contains the files, models, service, and host.json. Now let me explain you functions file. It contains the resume analysis function.cs. It is the file that contains the logic for analyzing resume. The function listens to the service bus queue for new resume messages. When triggered, it downloads the resume from Azure Blob Storage, sends it to the Gemini AI for analysis, saves the resulting report back into Blob Storage, and then publishes an event to event grid to notify other systems. It also includes error handling to log problems if something goes wrong. In short, this function is the heart of the resume analysis process. Now, it is the attribute that tells Azure this is an function. Pass the JSON message from the service bus. Then it downloads PDF from that blob storage. After downloading the PDF from the blob storage, it extracts text from the PDF using PDF pig library. It called Gemini AI for analysis. Then it saves report.json to blob storage after Gemini AI does the analysis of the PDF. Then it publishes event to the event grid. Now let me tell you how Gemini AI works here. We send Gemini two things: the full text of the resume and the job description. We ask it to return a JSON response with a score from 0 to 100, match skills, missing skills, and the recommendation. We use response MIME type application JSON to force Gemini to return only JSON file. No markdown, no explanation text. We also use try get property instead of get property when reading the response. This prevents crashes if Gemini returns incomplete JSON. So in this way, resume analysis function works here. Now, let me explain the models file. These models define the structure of the message and reports used by the function. Resume analysis message represents the information received from the queue, such as job ID, job description, applicant email, and submission time. Resume analysis report represent the analysis results, including the overall score, summary, match, and missing skills, recommendation, and when the report was generated. They ensure the function knows exactly what data to expect and produce. The third one is the service file, which is an Gemini service.cs. It is a main file in the function app. This file connects to Google Gemini AI to perform the actual resume analysis. It builds a prompt with the job description and resume text, sends it to the Gemini, and expects a JSON response with scores, skills, and recommendation. The service includes retry logic if Gemini fails, cleans up the response, and safely extract value to build the resume analysis report. In short, this file is the bridge between your app and the AI service. We are sending you the prompt in this way. Then the then it is the retry logic for quota exceeded error. For example, if API is invalid or it has finished its quota, then we pass the JSON in a safe way. It never crashes. Important point. Never hardcode your Gemini API key in the code. Store it in Azure Key Vault and read it through the configuration system. We show the correct way in the code, reading from iConfiguration, which pulls from Key Vault automatically. Now, let me explain you host.json file. The host.json file configures how Azure function runs. It sets the runtime version, controls how service bus messages are handled, and defines retries rule. For example, it ensures resumes are processed one at a time, prevent automatic completion until the function confirms success, and retries failed task up to 3 times with a 10-second delay. This file makes sure the function runs reliably and safely. So, the summary of the ResumePulse.function project is that it defines the model to define the shape of the data. It contains the setting file to configure the app for different environment. Then we have the function to contain the logic to process resumes. Then we have the models inside function to structure the message and reports. Then we have the Gemini service which connects to AI for analysis. At last, we have host.json that controls how the function runtime behaves. Together, these files form a complete system. Resumes are uploaded, analyzed by AI, stored securely, and results are shared reliably. Let me explain you one important file, local.setting.json. So, it is a file for local development only. It contains real security. It must never be committed to Git. In Azure, these values are set as the environment variable in Azure portal. So this is all about the ResumePulse.function folder. Now, further, I will explain you what is ResumePulse.client folder. Let us start with ResumePulse.client folder. Before starting with the folder, I would like to explain what is Blazor WebAssembly. Blazor WebAssembly is Microsoft framework for building web API UIs using CHAS and .NET. Unlike traditional web apps where the front end is JavaScript, Blazor compiles your CHAS code to WebAssembly, a binary format that runs directly in the browser. This means you can build a fully web app using only CHAS, no JavaScript required. Now, let me explain you the Blazor configuration file, which is program.cs file. Now, what is program.cs file? This file is the entry point for the Blazor WebAssembly client applicant. It sets up the app, defines the root component, and configures services. It decides which API based URL to use, the Azure hosted API in production or the local server in development. It registers an HTTP client with that base address and adds the Resume API service so the app can upload and call for reports. Finally, it builds and runs the applicant In short, this file is the bootstrapper. It initializes the Blazor app, connects it to the right backend, and ensures all services are ready before the app starts. We are using different API URL based on environment, that is development and production. It registers HTTP client with the API based URL. Then we register our custom service, which is Resume API service. Next, I would explain you the Blazor homepage. Now, this file is the front-end end user interface where user interact with your ResumePulse. It provides a form to enter an email, paste a job description, and upload a resume PDF. Once submitted, it shows a step-by-step progress tracker, uploading the resume, queuing it for analysis, AI processing, report generation, and email notification. When complete, it displays the overall score, summary, match skill, missing skill, and recommendation. In short, this page is the user-facing part of the app, guiding the user through the process and presenting result clearly. One critical bug and fix. In Blazor WebAssembly, when you select a file using input file component, the browser file response is only valid in the same synchronous content. If you try to read the file after an async method call, that is await, Blazor has cleared the reference and you get a null error. To fix this, you have to read the file into a byte error immediately in the on-change handler before any async gaps. Then use the byte array instead of the original file reference. Please keep in mind when building the homepage.trezor page in WebAssembly. Now, let me explain you the client service, which is an Resume API service. Now, what is Resume API service? So, this file manages communication between the Blazor frontend and the backend API. It defines two models, Resume upload response and analysis report, which represent the final analysis result. Resume API service classes uses an HTTP client to send and receive data. It has two main methods, upload upload resume async, which uploads the resume along with the job description and email, and poll for report async, which repeatedly check the backend until the analysis report is ready. In short, this file is the bridge between the front end and the backend, ensuring resumes are uploaded and reports are retrieved. Now, this is the function which upload or send resumes to the API. Then we build multi-part form data like an HTML form submission. Then we check every 5 seconds if report is ready. After 87 seconds, it return null. So that's all about the Resume API service and all about the ResumePulse.client. So we have covered the three folders, that is ResumePulse.api, ResumePulse.client, ResumePulse.function. Now next we are going forward to the deployment to Azure. So before deploying to the Azure, let me tell you, we need to check for the build errors. To do that, we open your terminal with Ctrl J, then change the directory for each of the file. For example, I am changing into the ResumePulse.api. Then run for the command .NET restore. It will restore all the files, all the packages present in the API folder. Then we have, after it is done, we have to give .NET build. It check for the build error. It ensures that our folder doesn't have any of the error. After the build is successfully, then we are good to go to deploy the ResumePulse.api. Now next, we will try with the ResumePulse.client folder. We will do the same thing. First of all, .NET restore to install all the packages present in that folder. Then we will check for the build errors using .NET build command. Once we are done with the ResumePulse.client folder, we will go with the ResumePulse.function. So we will do the same thing. First of all, .NET restore and then .NET build. It makes sure that we do not have any error in the files. As you can see, in each of the file or in each of the folder there is no error for me. Make sure you also don't have any of the error. Otherwise it will be problem for deploy. Now as you can see, I have not got any of the error. So we are good to go to deploy our app. So first of all, let me clear the terminal. Now I will show you the deployment in two ways, using the Azure CLI command and using the Azure icon. First of all, let me show you using the Azure icon. So in the VS Code left bar, click the Azure icon. Then expand the Azure subscription. Expand the Azure App Services. Then right click on the Azure App Services you have created. Right click it and deploy to web app. Or you can do in this way. Go to your main folder. Click on the ResumePulse.api, right click to it and select the deploy to web app. After deploying to web app, it tells us to deploy to the web app. So you can click on deploy. I have already deployed it, so I do not need to do it once again. Or the you can do it for the both for resume.pulse.api as well as resumepulse.client. For resumepulse.function, right click on it and select the deploy to function app. Then I will show you using the commands. So I have created the file for deployment. You just need to copy all the commands and paste it. I will explain each code what is does. Now first of all, let me tell you. First of all, we need to change the directory from pulse.api. Then we have to select .NET publish command. This is a command which builds the API in a release mode, optimized for production, and it outputs all the files to the publish folder. Then after it is done, we need to create a zip file to Azure App Service. Azure extracts it and configures the runtime and starts the app automatically. Then we have the deployment command which deploys the zip file to the Azure App Service. So this way you can deploy all the three folders. After once the deployment is done, let me show you the deployment URL from which you can test your application. Before checking the deployment URL, we need to do some changes. So go back to your Azure portal and search for the app services. Click on the app services. Go to your app service. Then go to your environment variable under the settings and click on add and enter the storage connection string. You can get the storage connection string from the storage account. Go to storage account in another tab and select the storage account. Go to your storage account. Go to the access key under the security plus networking tab and copy the connection string for the key one and paste it here. I have already applied it, so it is giving me the error. So once it is done, you have to add one more, that is service bus connection string. Write the service bus connection string, then go back to the another tab and search for service bus connection. Once you are gone to service bus, select your service bus, then under the setting, click on shared access policy. After that, select the root manage shared access key. After that, select the primary connection string. After copying the primary connection string, then paste it in the value here. Once it is done, click on apply. Then once again click on apply, then click on confirm, and then go back to overview and click on restart the app. Once you restart the web app, then check whether you have already added the storage connection string as well as service bus connection string. Once you are all done, then we are good to go to check the deployment URL. So copy the command. So first we need to install the Azure Static Web App CLI. When you have copied the Azure app static app CLI, paste it in the terminal. Once it is installed, copy the second command. Now see here, you need your token key. So to get the token key, so go back to your VS Code and enter the command edgehead static web app secrets list --name and your static web app name. After selecting the static web app name, copy paste here and then enter the --, resource group and enter your resource group name. Once you get the response, select the API key, which is your deployment key. So go back to your command and select your command and paste it in the terminal. Now copy your API key and remove the your token here and replace with your token. Once it is done, click enter. So why we are deploying Blazor WebAssembly to static web app? So Blazor WebAssembly compiles two static files, index.html plus WebAssembly binaries. Azure Static Web Apps is designed exactly for this. It serves static files from a global CDN, handles routing, and support custom domains. The free tier is completely free forever. Also, keep in mind before publishing, update the production API URL in ResumePulse.client, where I will show you that how to do that. Now, once your project got deployed, go back to your ResumePulse.api, go to your program.cs and enter your static web app URL, which is this one. After you have done this, copy your app service URL and go back to your project and in ResumePulse.client, go to the program.cs and copy the URL here. Once it is done, then publish it again. Then you are good to go. When you click your following link, open it in your browser and you can see our app is successfully deployed. So congratulations, you have deployed your first static web app and you have done all the project in the Azure portal. So you have got the knowledge about the Azure portal. Let me show you whether it is working or not. So you can see it is working. So that's it. And that is our ResumePulse.ai. So you can check your post deployment checklist and verification. You can check your API health check, function deployed, key vault secret, service bus queue, static web app URL, and cross updated. Then after that, you can check your live demo. Once it is done, you have learned cloud architecture, 9 Azure services, security best practices, code and development, deployment skill, real world bug fixes. So, and that is ResumePulse, a fully deployed production grade AI application built entirely on Microsoft Azure free tier. Let me summarize what we built and what you will learn today. We use 8 Azure services, blob storage for files, service bus for messaging, Key Vault for security, App Service to host the API, App Service Plan as the compute resource, Azure Functions for serverless processing, Event Grid for event routing, Logic Apps for email automation, and Static Web Apps for the frontend. We wrote clean .NET 9 code, integrated Google Gemini AI, built a beautiful Blazor UI, and deployed everything to the cloud. If this helped you, please hit like and share. It genuinely helps more developers discover cloud development. Leave a comment below with what project you want to see next. The full source code link is in the description. See you in the next one. Thank you.